Okay, so we are live. Welcome to everyone watching, either live or maybe in the future, to this year's presentation, the final showcase of Google Summer of Code and dedicated mentorship program, Code for GovTech students and contributors. So this year's cohort is going to share their projects, which vary from music blocks V4 and V3 to GTK4 to sugar activities to a cool new way to help students create their own activities, as well as Sugarizer. So, and also some back-end things which are really exciting. So each contributor has been given 7 minutes to give their presentation, and they've been asked to, state the problem that they're trying to solve, share their solution, their approach to solving that problem, as well as how far they've gotten this summer. Everyone has done a lot of work, so it's impossible to kind of put everything into those 7 minutes. So you can track their work further at sugarlabs.org. You just go up to the news page because each one of the contributors has, created a blog post over the summer, as well as you should be able to find their final reports by, following links in there as well. So I encourage you to go to sugarlabs.org, follow all our work, but in particular, after watching this, go to the news page. So we do, behind each contributor are, mentors in the Sugar Labs community. I myself am one of those mentors, but we have a few more mentors, and I've given those who could attend, because we've got different time zones and different commitments, a chance to just, say a few things before the students begin. So I believe, Walter, you were going to go first and say a few things.
Sure. I can even try to turn my camera on. Hi, I'm Walter Bender, and I was maybe the primary mentor for a few and the assistant mentor for many of the projects this summer. And last summer was really, I think, sort of the summer of AI, or really the last 2 summers. We spent a lot of time focused on AI projects at Sugar Labs. This summer it's been a much more diverse collection of things going on. And I think what it's been about this summer has been to make things actually be useful and usable and appropriate for our audience, our users. So there's been some AI in that mix, but there's been a lot of other exciting work that has nothing to do with AI that I think is really critical to any project being both sustainable, maintainable, but also serving the needs of our users. So I want to thank everyone who worked this summer on their various contributions that were really quite broad-ranging, much more broad-ranging than anything we've had in the past. Devin, do you want me to speak to individual projects when they come up, or?
Yeah, well, that's if we have time in between.
Right. Okay. All right.
Yeah.
So I think we'll just get started with the students then.
Yeah. That sounds good. First up, we have Dev. Dev, are you ready to share?
Yeah, of course.
Great.
I'm ready.
Yeah, go ahead.
Share my screen.
The floor is yours. So Dev worked on GTK4 transition part 2 sugar shell, and probably some other things, but that was the official title.
My screen is visible.
Yes.
Yeah. So hi everyone, I am Dev, and this summer I worked with Sugar Lab as a GSoC contributor on the project GTK4 Transition Part 2 of Sugar Cell. So the goal of my project is to migrate the Sugar Cell desktop from GTK3 to GTK4. As Also while moving the shell, I also migrate the display server from to Wayland as like the GTK3 is approaching its end of life. So we need to migrate the Sugar Cell to GTK4 to stay its compatibility. So that's all I did. Uh, these are my blog posts, which can be find easily uh, in that folder. So the main part of my migration was done in the Sugar repository. So in that, it was a major pull request where I migrated the whole Sugar cell. Also, while doing this, I also as the toolkit GTK4 toolkit already migrated through our mentor. So I just implemented some changes that need to be supported in the Sugar cell, also in the Sugar extension library, and also I added uh, in the Sugar artwork a GTK4 theme in that the drop down trees control panels all were newly migrated for the GTK4 cell. So now I will show you like I will show as a complete desktop. So is it visible?
Yes, it is, and it looks very nice. I like that background.
Yeah. So this is my Debian testing environment where I tested the migrated cell. So uh, this is the Sugar home view. So the Sugar home view is the starting point where a student launch and manage the activities. So the this was a XO icon that was like presented in the center, and surrounding it, these are the activities. So and like this was the frame, like it was a centerpiece of our Sugar cell. Like it's provide navigation between different views, and it also shows the running activities and contains system and clipboard functionality. So this is also where the user can switch while between running the activities. So now I will launch activity. So this is a list view, yeah. Maybe it's started. Yeah, so it's a browser activity that properly work as I implemented a Caslia socket in that so that it worked properly. So here I run it. Yeah. So now it's work properly. Yeah. Just a network issue. Little bit. Yeah. So the with the activity running, the frame keeps the cell navigation available, like so that the managing activity life cycle rather than the simply acting as it as a launcher. So while running an activity through the frame, I can navigate directly through the home view. So now let's move to the general. So yeah, yeah. So another important part of the Sugar cell is the journal. So the journal is where the Sugar keeps the student activity history and save objects. So I migrated its view, also the search references, toolbars. So also these filters and GTKs like detailed views to GTK4. So let's like yeah. Apart from that, there is one also important part that was in my setting, like the control panel was the major part of my migration. So here you can see the migrated GTK4 setting references, including keyboard, language, date and time, and also this was about me section. Let's open it. So this was the information of mine. Like here, student can change the gender and grades and all of that things. After that, here I can all like, and this was the background section. Let's change the background and think. Let's see. Yeah, it's working properly. So now let's move the software updates. Yeah. So this was the major part of my migration. So uh, the also there is a less visible but more important part of that migration. What is these pop-ups? So like GTK4 remove the old menus and pop-up patterns that Sugar relies on. So so these interaction have to be adapted to the GTK4 pop-up and variant behavior. So like also like that was the main view, and let's neighborhood view and like see the switching over this through functions keys. Yeah. So so the result of the project is a GTK4 based sugar cell with the core desktop component migrated together with the supporting toolkit and the extension and the GTK4 artwork changes required to run it. So now the cell has to browse onto the variant path through Caslida, and I tested the migration all these in my Debian environment with all while inserting those activities that are migrated this year. So, thank you. Yeah, that's all from my side.
Awesome. Thank you, Dev. So you work together with Divyam, correct?
Yeah.
Yeah. So I have Divyam couldn't make it, at this time slot, but he shared a recording, and I'm going to share that recording of his presentation. I realized just now that I hadn't tested the sound for this, but so please tell me if the sound is not working. But I did all the right things, so hold on a sec. Interface is different when it's smaller. There it is. Okay. Okay, so this is his presentation.
I think you had the sound off on the video playing. Oh, no, I hear it now.
Oh, it's muted here.
GTK4 transition.
Okay, can you hear it now?
Everyone, I am Divyam.
Did you hear that?
Yes.
Okay, then I'll start over.
Yeah.
Okay, here we go.
Everyone, I am Divyam Agarwal. So this summer for Google Summer of Code, I worked with my mentors. First is Ibiam, Walter, Mentor, and Krish on the GTK4 transition project. Specifically, part 1, Fructose. So the main problem we are trying to solve was that most of the fructose activity was still using GTK3, which is a big problem as nowadays it is shifted for GTK4. And well, GTK3 has worked really well for sugar for a long time. So the big challenge is that we have to, uh, what we say, migrate the things from GTK3 to GTK4 because as it is type of a legacy thing, because it is pretty much old now. There are so much issues with newer Linux system, especially with Wayland. So if we keep these activities on GTK3, it is very hard to maintain and even harder to work on these things. And eventually they might not work properly on newer systems, which makes them very difficult to upgrade them, which is makes very difficult to work on the activities by the developer, which is very much difficult to showcase the new activities or to update the things in this GTK3 version. So the goal of my project was basically to move these activities over to GTK4, but without really changing the experience of the users. So I give my best efforts to do this. So and that means going through the activities one by so I'm going through the activities one by one, figuring out what had changed between GTK3 and GTK4, and then fixing the things that broke along the way. And yeah, that's ended up quite a few parts of the code base, involving quite a few parts of the code base. Moving these activities to GTK4 was kind of a like try to change the foundation of a house without moving any of the furniture inside. So a lot of work was basically making sure when a student clicks on something or drags something around, it still reacts the way they expect it to, and that's how the migration is working, such that whatever be the things which is previously worked on, it should mandatorily be worked on when we migrate the things. So the one of the biggest challenge was I feel is definitely a turtle art, and it has so many interactive parts like snapping the puzzle pieces together, the drawing area, and all the different tools. As it contains many tools to integrate them to work on these, it makes me hard. It makes me harder to integrate all of the parts. So overall, I feel that turtle art is somehow difficult for me. So yeah, I had to be really careful that none of those things broke during the transition. The whole goal was basically to do a ton of work behind the scene so that for the kids, teachers, and anyone who use this application for or whoever be our user, it looks like nothing really changed at all. It feels the same even when the code base is transitioned from GTK3 to GTK4. And that's my and our team whole goal. All right, let me jump in and show you how it really looks in action. So please take a look. So, so okay, let me open the calculate activity running on our GTK4. So as you can see, it launches normally, and let's see the graphs and equations are rendering properly. Let me show you how these graphs shows on our GTK4 layer. Let's look like this. This is a perfect parabola on X square. Now, as you can see, it launches normally and the graphs and equation are rendering properly. So now we have over go to our turtle art. So that, as I previously mentioned, it was one of our bigger challenges because there are so many interactive parts, so many uh, insights. So it's a bit, I would say, a cluster of activities inside this turtle art. But as you can see, the blocks will snap together just like before, and drawing canvas is working as expected. See how it works. So yeah, the whole idea was to do a lot of work behind the scenes so that for the users, it basically feels like nothing has changed. That's how it works. Now, if you want, go into the techniques or see how some of these problems were solved. I have linked my porting guide in my final GSoC report. You can see in my porting guide on GSoC report. And yeah, that's pretty much it. I want to thank you all my mentors for all their help, guidance, and my peer ones as well. To throughout this summer, they helped me a lot for any difficulties I faced during the whole inside summer. Thank you, everyone. Thank you so much.
Well, that was exciting to see. Mostly Krish, congratulations on leading this team this summer. Really, really great progress. And I think, again, we need to make this transition to be maintainable going forward. And it looks like you guys really, really nailed it. So congratulations for that. Thank you. I did have one question for Dev, which is I put in the chat. Is the transition from X11 to Wayland complete, or is there still more to do to work on there?
Yeah, it's completed.
That's great. That's great. That's
Yeah.
another huge forward-looking change for us. So congratulations on that.
Yeah, thanks.
We're entering the modern era. So that's great to see. Thanks. Back to you, Devin.
Okay,
Thank you.
yes. So that concludes the GTK4 portion of the presentation. So let's give Dev and Divyam another, round of applause. So next, we're moving on. We're kind of going in topics, but music blocks V3 is like a big topic, so that's a little split up. But we're going to move into that for just a second for a few presentations, starting with Shreya, who led us with music blocks performance, which was a super important project, at least in my opinion, because it impacted so many students and teachers that were, using the program. So, Shreya, you have the floor.
Am I audible?
Yes, you are.
Okay, let me share my screen.
We can see your screen.
Okay, so let me get started with. So, hello everyone. My name is Shreya Saxena. I am a GSoC 26 contributor at Sugar Labs, where I worked on music blocks performance. I joined Sugar Labs around the end of December, initially just to explore the community, but I really enjoyed it and eventually started contributing. I chose Music Blog's performance project because for a developer, performance is usually about things like latency, rendering time, or milliseconds. But for a child, it's much simpler. If their project takes a long time to load or stops responding, it interrupts their idea and their creative flow. So that's what motivated me to work in this project. So, to improve performance, I first needed to know where the time was actually going. So, I created benchmarks, profiled the important workflows, identified the real bottlenecks, made optimizations, and ran the same benchmarks again to validate them. This measure to identify, to optimize, to validate cycle guided most of my work. After the filing, I found a few major problems. For example, large projects like Rainbow Connection with 5,000 plus blocks were taking more than 20 seconds to load. I also found audio timing drift issue, which was the major breakthrough I worked on, unnecessary canvas rendering, runtime stability, and node duplication issues. So these became the main areas I worked on. I looked at music blocks as a pipeline with 5 areas. Step 1 was the logo execution engine. I checked the core interpreter and runtime, but profiling showed that it contributed less than 1% of the playback time, so it wasn't a bottleneck. Step 2 was the block execution, where I looked at block processing, block highlighting, but even after the block execution, I couldn't find any of the major bottleneck coming in. So it was again not the major time was going on. Step 3 was rendering. This is where I found the significant. Step 3 was something which I investigated a lot, where Crep Cannon plot was my major benchmark I used. So music blocks was rendering blocks that were outside the visible area. So I even worked on that. I'll be discussing this very soon. Step 4 was the audio scheduling. I found that browser timers were introducing latency and timing drift, which led to the tone dot transport optimization. Step 5 was the memory management, where I worked on cleanup and runtime states so that leftover timers and resources wouldn't affect the repeated runs and stability. So here, one of the major breakthrough was changing how music blocks schedule audio. Previously, every node used set timeout, which depends on the browser event load. A small delay in one callback could affect the next one, gradually causing timing drift. I replaced that with tone.transport, which schedules the nodes on the tone.js audio timeline. So I used Fairjax as the major benchmark for this, and the callback latency was dropped from about 45 milliseconds to 12 milliseconds, and which was a major improvement in the runtime performance. So next we come to the canvas render. So here I used script cannon plot as a major benchmark. So the main issue was that music blocks were spending time in rendering blocks that weren't even visible. I added viewport culling, allowing off-stream blocks to be skipped. This could reduce the stage dot update from 4.8 approximately to 1.97 milliseconds, around a 59% reduction. But this is still a performance issue where all blocks in Cannon plot are visible, so that still remains an area under investigation. Okay, so then after the runtime performance, I come to the loading and exporting part. I worked on loading and notation export with Rainbow Connection as my primary benchmark. So loading sometimes take more than 20 seconds and export could, what I profiled, it was taking more than 33 seconds to export, specifically for save as Lilliput. So Volker suspected that unnecessary re-rendering during loading could be a bottleneck, and profiling confirmed it. The canvas was being re-rendered about 33,400 times, while the loading screen was still visible. I suppressed those unnecessary renders and performed a final render after loading. And for export, I introduced a faster execution path instead of waiting after every block. I would like to show the demo of before and after so that we can actually understand that how the loading was happening in music blocks before and how could able to optimize it. So we can see like before optimization, it was literally taking a lot of time to load. Um, Major pause, you can see. And after I optimized it, according to me, I could see like every project could be loaded in less than 10 seconds. Then for Lilliput export, this was actually taking a lot of time to export if I include MIDI output as well. So this was genuinely a big issue in music blocks. I profiled and worked on. And after optimization, it could happen instantly.
Yeah, that's a big
So
difference.
after yeah, exactly. So after these results and the optimization, the main results are something which is visible on the screen, that the rainbow connection loading improved from about 19.4 seconds to 9.5 seconds, and notation export improved from 33.6 seconds to around 1.46 seconds, making it about 23x start faster. For audio mean latency, it went from 45 milliseconds to 12 milliseconds, It was again like one of the major improvement, and rendering was also improved significantly. So yeah, the biggest challenge was finding the real bottleneck in the large code base. Sometimes something looked expensive, but refiling showed that optimizing it would barely make a difference. Like the first two stages, another challenge was also validating improvements because performance can vary across browsers and runs. And because music block features are interconnected, changing one part could sometimes affect another. So I relied on measurements and repeated runs rather than judging whether something felt faster. Okay, so looking ahead, I'm currently exploring how Perfsense, it's one of my personal projects, it could potentially be adapted for music blocks. The idea is to establish a performance baseline, compare new changes against them, detecting meaningful regressions, and alert developers when performance gets worse. It's not currently integrated, but I'm still figuring out whether and how it could be useful. And I think even future contributors, if they want to contribute in this domain, can explore such areas. So, before I wrap up, I would like to thank my mentor, Walter Bender, for his constant guidance throughout the project. I would also like to thank Om and Devin for their feedback and support, entire Sugar Labs community for being so welcoming, and finally, this project comes up with the goal I started with that students they should not spend their time waiting for music blogs to respond. They should spend their time rather create. Thank you.
Fantastic.
Yeah.
Yeah, I mean, I'm going to speak for Devin for a second. It's Devin's the real musician here, so the performance improvements in terms of playback are really important. But Devin's also the classroom teacher, and you're just taking the wasted time in the classroom away, so that at the point you just made, so that the time is really spent on the project is hugely important. So, congratulations, great work. And from the developer and me, having a systemic way of measuring performance now in music blocks is going to be super important going forward. So, thank you.
Yeah, I love how you broke down the problem, and from there you identified the real bottlenecks, because there was some like red herrings and things like that. You are not the first person to attempt you know performance improvements. At the beginning of the summer, I said it really should feel faster. And I can say for certain that it feels a lot faster now. The performance improvements that you made are real. And the other day, I don't know if you realize it, but you reached another milestone, because before I wasn't able to use music blocks on the Sugar Desktop's browser, but now I can. So that's a new milestone. So congratulations.
Thank you. Thanks so much.
Okay, so we are moving on to more Music Blocks V3 contributors. Next is Abhnish.
Hello, hello, am I audible?
Yes, who's going to present enhancements to meet WCAG 2.1 standards. So you can talk about that more. I give you the floor. And Shreya, if you can stop sharing your screen, please.
Let me just share my screen.
Yes, we can hear you, but you might want to speak up just a little bit louder.
Yeah. So, hello everyone, my name is Abhnish. So today I'm excited to share my work on making the music block and enhancing its accessibility and making it fully accessible to all the users. So to give you a quick overview, so my project was focused on upgrading music blocks to meet web content accessibility guidelines, accessibility standards. So before this project, screen reader users got zero audio feedbacks because the main canvas was totally invisible to their assistive technology. Second, keyboard only users were stuck. Pressing the tab key did absolutely nothing. because it was blocked by the code, making the app impossible to navigate. And finally, low vision users struggled because there was no high contrast mode, and an automated scan found 16 critical accessibility violations. So, to solve these problems, we set 5 clear goals. I can say that we achieved all of them. So, we completed a full audit report to find every issues and gaps. We verified a working high contrast theme. We fully restored keyboard navigations, and we added real time audio announcements. Also, I made sure every single button and menu had a proper readable text label. So here how we solve the visual and navigation barriers for low vision users. I verified a high contrast mode and with highly visible black, white, and cyan theme. So let me show you the. Uh, so here's the high contrast mode. I verified it and it was according to the WCAG standards. So so for keyboard user, we remove the block on the tab key. So now user can easily move through the toolbar, menus and widgets. And there is a bright blue focus ring you can see that shows them exactly where they are on the screen. So let me just see here how you can navigate to the platform through tab keys and your buttons. So moving forward, our biggest and most important update was adding screen reader support so blind students can hear what is happening on the screen. Instead of just talking about it, I want to show you exactly how it sounds. And here is the video that how it's implemented. Yeah.
I don't think you have the audio on for your. We're not hearing it.
Okay.
Yeah, so when you share your screen, you'll need to select share audio, but also it kind of depends on what browser you're using because I'm not sure if it works on Firefox,
On
but I know it works on Chrome.
Yeah. Is it not audible?
Well, you have to stop sharing and then you have to share again, but we can't hear that. No, I can see the feedback, which is helpful. So if it's not possible, what we can do is we can just share a link to the video afterwards.
Yeah, sure. So
But I'm presuming that that thing that it's saying in the dialogue at the lower left, it speaks. Is that correct?
Yeah, it speaks. Yeah.
Yeah.
So moving forward, so this is how it will. So moving forward, so the app now speaks to the user. It announces when blocks are connected, tells you exactly what menus are open, and read buttons, descriptions, and all. So I want to share my learnings which I learned working on this project. One of my biggest learning moments this summer was realizing that shipping code is not just as same as working feature. Like automated scans are helpful, but they don't catch everything. To make sure the app was truly accessible, I manually tested the whole platform using only voiceover. I found critical bugs there. For example, arrow keys were trapped and broken inside 15 different menus. And also, some of the background website code was actually confusing the screen reader. causing it to read some wrong words. So I had to manually go in and rewrite these sections to make the audio feedback perfect. So let's look at the final result by the numbers. This is the impact. So we reduce our initial WCAG violation, which was 16 before. It is down to 0 right now. I raised 25 pull requests for this project, and 22 of them are already merged. And I also published 2 complete audit documents regarding touch support and WCAG audits. And I wrote a one full proposal document mapping out our next step. So moving forward, what's next? So this is the result for the WCAG violation reports. It is right now 0. It was 16 before. So moving forward, so accessibility is a ongoing journey. So moving forward, we are focusing on 2 big major areas. Like first, mobile touch support. So I am trying to go for a fix for Android navigation to make sure touch targets are large enough and blocks are easy to track with a finger. And second, we are expanding to support the cognitive and learning disabilities like dyslexia and autism. So this will actually ensure better accessibility to all the users. So with that, thank you so much guys for your time, and thank you again to Sugar Labs, Devin, Walter for this opportunity. It was great to collaborate with this community. I learned so much. Thank you so much.
All right, well, thank you so much. We've been really remiss in that, we want to make sure that music blocks and sugar in general are accessible to everybody. But also, accessibility enhancements tend to improve the quality of the interaction for everyone, not just for people with some kind of access limitations. The other thing is, it was really ironic that Music Blocks, which is so focused on audio, wasn't accessible as audio, and so that is a great enhancement as well. It's really great to be on the right side of that issue now. The other thing is, Abhnish, you and I have been discussing. We're going to be migrating away from an old library for the rendering, Great.js, and when we do that, we're going to migrate over to a DOM-based approach to the problem of rendering on the screen, so that in fact we can make all the blocks be accessible as well. So thank you for leading us through this journey, and really looking forward to getting this out into the world.
Thank you so much. Thanks.
Awesome. Yeah, thank you so much. I echo everything Walter just said. Looks like we're back to being exactly on time with our schedule. So we got to move on next to Nirav Sharma, who took on an impossible task, refactoring Temperament. So you have the floor, Nirav.
Let me share my screen.
Yeah, and if you can speak up just loud and clear so everyone can hear you.
Yeah, is my screen visible?
Yes, it is. But yeah, keep speaking up loud because you've got a noise level that's like almost equal to your voice.
Okay, so
there you go.
I got the Refactor Temperament project for DMP, and it has initially 6 goals. First of 3 was to refactor the full temperament layer for music blocks. So the initial problem was that there were frequencies calculated by pitch, number, pitch, frequency, and some math behind it. So that was entirely hard coded in 12. So I just changed the hard coded to current edo function and made a new function that outputs the notes according to the edo you choose. So the first 3 goals were just so the frequency will be computed correctly for all EDOs and all non-EDOs, not just 12. So I was originally going to make a cool project, but it broke at the end. Oh, sorry. So this is a demo project. As you can see, this is 12 EDO, and the
I'm just going to interject a second. So Edo means equal divisions of the octave. So
it is divided into 12 octaves, but some uses 1930, some system uses 1931 EDOs according to the use. So the main problem for is the calculation, and I refactored the entire temperament so it works correctly for any EDOs. So now for the fourth goal of my project was scale and builder mode. So music blocks has a built-in mode fixed to 12 semitones, and the custom mode option has no real interface behind it. So I will it. The use case of scale and builder mode is to make a custom mode to your choosing, and you can even tweak the pre-existing modes. So this is how you make a custom mode. So let me refresh. Yeah, so this is how you make a custom mode. So previously it was just accessible for 12 edo, but I made so you can access any edo like 17 or 31 and etc. And non edos as well. So this is how you make a custom mode. Let's say I want to make a custom mode for 12 edo. I choose the intervals I want. And name it whatever I want and save it. I can save and delete the custom modes according to me. So this is the custom mode, and I can use it from here. And I can even tweak the pre-existing custom modes as well. Let's say I want to tweak the harmonic minor. These are the intervals for that, and I can like remove some intervals and make it my own as well. So that concludes the goal 4. Now, moving on to the goal 5 for my project is temperament visualizer widget. So the current circular diagram in the temperament widget shows the node position but has no real reference point. So you cannot tell whether any pitch is sharp, flat, matching standing units, or etc. So I made a yeah UI behind it. So this is temperament visualizer. You can compare any IDO with 12. Like let's say I wanna compare the compare my 5 IDO with 12 IDO. So the this lines means red means flat compared to 12, and yellow means sharper compared to 12, and green means there's no deviation, and etc. I can even compare it with 19 if I want, and 17, any IDO, non-IDO, and I can even tweak the pitches to whatever I want. I can add new pitches or remove if I want. And there's a full table to show that the calculations and stuff, the numbers of the hertz and standard deviation and ratios and all. That's all. That's from my side.
Awesome. Thank you so much, Nirav. I know this was a challenging task, and it's somewhat, can be a somewhat abstract concept, but at the same time, that's what makes music blocks so powerful. It can take these somewhat abstract musical concepts and then make them more tangible for the user.
Just before we leave the topic, so one of the ideas behind Sugar is that we have a low floor, but we have no ceiling, or as high a ceiling as possible. And temperament and mode are two concepts that, to Devin, they're natural because every musician needs to confront them really right from the very beginning. But it was just a revelation to me. But once you start digging into temperament and modality, it's an endless pleasure. So having those tools really finally working properly in music blocks is just fantastic. So congratulations and thank you.
Yeah, and I will say, so having these temperament features, it allows us to, gain, broader access to world music, because music from around the globe is not necessarily in the same temperament system as, Western classical music. So, we get access to that. We also get access to experimental music. Also, I will say, having worked on this for this long, you gain a greater appreciation of, if your whole world is 12 Ito, the kind of Western classical music and most classical music, you gain a greater appreciation of 12 Ito by exploring these other temperaments too. So it kind of works both ways. You go to 31, you go to 41, 57, and those are all awesome. And then you also go to 12 and you're like, well, that's not a bad system either. So, okay, so another round of applause for Nirav. Next, we've got Vanshika, who is going to present music blocks maintenance. So Vanshika, if you can unmute yourself, and you have the floor.
Wait 1 second. I'm sharing my screen.
Yeah.
Is my screen visible?
Yes, I can see it.
So yeah. So I am Vanshika and I'm in my second year. So I have been contributing to music blogs as part of my C4GT's dedicated mentorship program. So my project is music blogs maintenance, which is mentored by Walter Bender. So the kind of work I did here is about testing, refactoring, dependency upgrades, and now I'm working on the AST based automation. So music blocks is a big project. So it's been around for years. Lots of contributors. There is like lots of features, lots of contributors, and when a code base gets that much big and that old, so it quietly builds up depth. So not like bugs, they are like the blind spot. So like that's why my project uh, came like music blocks maintenance. So a bunch of the existing tests were running the code, but they were not really checking if it worked correctly. So like there are modules like turtle actions, logo, and activity. So these are the core pieces, but they had no basically they had no tests checking that they actually worked together. And the biggest gap of all, there was no test for the most like the most basic thing, uh, like which a user does, like load a project, hear music. So that flow had never been tested end to end. So like on top of that, dependencies like node and tone.js were overdue for upgrades, and one of the biggest problem, which is the activity.js file. So it's a single file which contains almost 8500 lines of code. So it has become so tangled that changing one small thing could break something which is completely unrelated. And you would not know until it breaks. So, what's the real problem? Uh, is about to refactor the activity.js and to structure the code base of music blocks. So, then I worked on like first I worked on refactoring the tangled stuff into smaller pieces that are actually possible to test. Then I worked on the mutation testing, which I will explain in a second. Like it is about to find tests that looks fine, but they would not catch any actual bug. So then comes integration testing. It is about to check things, if they can actually work together or not. Then comes end-to-end testing with Cypress for real user flows, then dependency updates, and the layer on which I am on right now. So it is using AST parsing to automatically figure out that what needs to be tested in a file. So, like, uh, this is my whole approach. So, first was the mutation testing. So this was probably the biggest part of my work. So normal code coverage tells you, like, did this line run? That's it. So it doesn't tell you if your test actually checks anything meaningful. So I used a tool called Striker to do mutation testing. So what it does, it literally goes into your code and breaks it, like it changes the greater than function to greater than equal to, or like flips true to false. Then it runs your tests and checks if anything failed. So if anything failed, it means that the mutant survived, and a survived mutant means that there is a blind spot. So I went through the turtle action modules one at a time, like the pitch, tone, rhythm, drum, meter, ornament, intervals, and running striker for all of these, and like to improving their coverage. So for pitch action specifically, in the next slide, here is the for the pitch action. So I have the actual before and after numbers. So before, the mutation score was 78.25% with 99 mutants surviving. So after strengthening the test, it went to 88.73%. So like that's the same for interval sections. So before it was 34.48, and after it becomes 48.05. So yeah, then next comes refactoring. So like I refactored the pie menus earlier before this project, and then I started working on the activity.js. So this was generally the largest, most file in the whole repo. So like toolbar logic, search, project loading, trash. So all of it I uh, separated out of from one file. I broke that apart across more than 15 pull requests into independent controllers, like grid controller, toolbar controller. So one each piece stood on its own, and I also added tests for the each files. So this is how the activity now looks after refactoring, and this is some of the widgets which I have worked on while refactoring. Then comes integration testing. So a unit test just proves like a function works when you call it right, but it doesn't tell you whether the app is actually calling it right in real life. So I like traced a path from the block, like from the blocks, like through the logo interpreter into the actual action, into the then singer or turtle state. Then I wrote tests through the pitch, volume, meter, tone, ornament.